Okay, I'm here on page 49 to remind you about what we've covered so far in gas laws. We've talked about Boyle's law, which was that pressure and volume are inversely proportional, P1 V1 equals P2 V2. We talked about Charles's law, which was that volume and temperature are directly proportional, V1 over T1 equals V2 over T2. We talked about gay-Lussac's law, which was that pressure and temperature are directly proportional, P1 over T1 equals P2 over T2. Now, we're going to talk about the combined gas law, which combines all three of those. It also combines a fourth one we haven't learned yet, but we'll get to. You can see here's the combined gas law, P1 times V1 over N1 times T1 equals P2 times V2 over N2 times T2. Here's the P1, V1, P2, V2 on top from Boyle's. The Charles, V1 over T1, V2 over T2 is right there. And gay-Lussac's P1 over T1 and P2 over T2 are also in there. And then this N, you may remember from earlier in the unit, that N is going to be our number of moles. And the N looks like it's coming out of nowhere, but there's actually another law we're going to learn later that will explain where that N came from. Notice that all of your 1 variables need to match units with the corresponding 2 variables. So like if V1 is liters, V2 should also be liters. If P1 is ATM, then P2 should also be ATM, and so on. Good news, everyone! You can start any problem with the combined gas law and just cross out the variables that are constant. So cross out the ones that don't change or aren't mentioned. For example, at a pressure of 405 kilopascals, okay, 405 kilopascals, that's a given. And they even told me that was a pressure. The temperature of a gas is 25 degrees Celsius, so they tell me that's a temperature, 25 degrees Celsius. Oops, my pen is my pen dead? How embarrassing for this to happen while I'm recording. Okay. I guess my pen's dead. It's okay. I have another pen that happens to be identical. Okay, so temperature is 25 degrees Celsius. They say if volume remains constant, what pressure will the new temperature be? So they say the new temperature is 0 degrees Celsius. And remember, new is code for 2. So that's T2, which means this is T1. And they're asking what will the new pressure be as well, so that means they're asking about P2, so this is P1. Remember, all of your 1 variables and your 2 variables need to match units, so if P1 is kPa, P2 should also be kPa. And if my unknown is kPa, my answer should also be kPa. So the equation that we can use for this, we can actually always, instead of having to hunt through our whole formula chart, for what is the exact formula we need, anytime we're using 1s and 2s, we can actually always start with this new one, the combined gas law. I can always start with this guy, the combined gas law. P1 V1 over N1 T1 equals P2 V2 over N2 T2. Okay, and in this problem, they said that volume remains constant. Volume remains constant. And if it is constant, we can cross it out. it says in our notes here, just cross out the variables that are constant. So if volume remains constant, I can cross out volume, I don't need it. And it also says you can cross out the ones that don't change or aren't mentioned. They didn't even mention moles, I can cross moles out also. And then I'm left with P1 over T1 equals P2 over T2. And I don't have to spend a bunch of time finding that specific equation on my equation chart. It was the very bottom one. That would have taken me so long to find. I can just always start with this one. It'll save me some time. Now, before we substitute, there's one more thing we have to do. Remember, we cannot use Celsius in these equations. We have to change this to Kelvin. So Celsius plus 273 is 25 plus 273 is 298 Kelvin. And then maybe cross out the 25 so you don't use it by accident. 0 plus 273 is, of course, 273 Kelvin. And again, you might want to even cross out the zeros so you don't use it by accident. Now we're ready to plug stuff in. P1 is 405, so instead of writing the variable P1, I'm going to write 405 divided by T1 was 298 Kelvin. So instead of writing the variable T1, I'm going to write 298. That equals P2, which we don't know, so I can write X if I want. I can also just write P2 and keep that as my variable. Divided by T2, which is 273, so instead of writing the variable T2, I'm going to write 273. Then again, if you know how to cross multiply, or butterfly method as some math teachers call it, you are welcome to do that. I usually take this fraction and simplify it first by putting it in my calculator and dividing. 405 divided by 298, which is 1.359 and some other blah 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 blah. That equals P2 over 273. To isolate P2, to get it by itself, I need to move this 273 over by doing the opposite of what's happening right now. So right now, 273 is being divided. The opposite would be to multiply that. So I multiply it here, and then if I multiply on one side, I have to multiply on the other side. And I'm getting 371.02 kilopascals. Okay, there are 4 problems for you to do at the bottom of this page, and the guess boxes are on page 50 for you. You can go ahead and label those guess boxes on page 50 for number 1, number 2, number 3, and number 4. And, yeah, that's all I have to say about the combined gas law.